welcome back. In this video, we're going to solve a differential equation, but this time, instead of finding the general solution, we're going to find a particular solution satisfying certain conditions. Here we go. So we're given a differential equation where the second derivative of the unknown function is e to the x. But the question is asking us to find a particular solution, which is called your function f satisfying initial conditions, where you have f prime at 0 equals 3 and f of 0 equals 1. Remember that when we talked about the antiderivative operation, we always add an arbitrary constant at the end of the differentiation process. So since we are going to do the differentiation twice for this type of differential equation, so we're going to have two arbitrary constants at the end of two differentiation process. And that means we are going to have the general solution depending on two arbitrary constants. So to get rid of this arbitrariness, we are going to use these two conditions to determine those constants. So eventually, we're going to find the solution without an arbitrary constant, and that solution is going to be called a particular solution. At this moment, I just want to remind you that if you try to integrate e to the x or find the antiderivative of the function e to the x, you get exactly the same function plus an arbitrary constant. And this is the rule that we're going to use in the next step. All right, I just wrote that rule here. So why don't we apply this rule to integrate f double prime twice? So if you integrate this one time, or if you look at the antiderivative of this function, that's going to be the first derivative of the function, and that is equal to the integral of e to the x dx. Let's use the integral notation here. But e to the x dx is e to the x plus c. Let me call this arbitrary constant to be c1 because I'm going to have another one coming up in the next antidifferentiation process. So our next step is to find the antiderivative of f prime, which is going to be f, and that's exactly what I'm looking for as the solution of this differential equation. All right, so now I'm integrating e to the x plus c1 dx. Right? I can use the sum formula for integration. And here we go. I have the integral of e to the x and integral of a constant. So for this one, I'm going to use this formula, and for this one, you're going to use the constant rule in the earlier formulas that I provided to you, or check the integration formula card to find the derivative of this constant here. So since I'm done with integration all the way, I'm going to add another constant, arbitrary constant at the end. So I'm going to call it C2. So the solution has 2 degrees of freedom, in other words, because you have two different arbitrary constants. And f of x is given in this form, and this is in fact the general solution of this differential equation. So that takes care of part A. In part B, we're trying to find a particular solution satisfying the initial conditions. So why don't we go ahead and then use these two conditions to determine those arbitrary constants. And here we go. So we have f of 0 equals 1. So all I'm going to do is function evaluation at 0. So f of 0 is equal to e to the 0. And this term is going to be gone, and plus c2. So e to the 0 is 1. So this is equal to 1 plus c2 equals 1. So the first initial condition provides us 1 plus c2 equals 1. And I can go ahead and solve this equation for c2 by subtracting 1 from both sides. So in turn, I get c2 equals 0. All right, let's try to use f prime at 0 equals 3. I know the description of f prime. It's right here. So f prime evaluated at 0 is e to the 0 plus c1. All right, e to the 0 is 1. 1 plus c1 is equal to 3. All right, subtracting 1 from both sides yields c1 to be equal to 2. And for c2 equals 0 and c1 equals 2, the particular solution to be equal to e to the x plus 2x. And remember that this was the general solution, so general solution versus particular solution. And what was the difference again between these two solutions? Well, the general solution has the unknowns in it, the arbitrary constants involved in it. Okay? And a particular solution is just one of those solutions satisfying these two initial conditions, and your particular solution should not have any arbitrary constants anymore after you use these conditions. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.